All right, we are multiplying integers, and you are going to find the product of integers. So first of all, in case you didn't know, multiplying and product, same thing, okay? The product is the answer to a multiplication problem. So there you go. Now, I'm going to start off with kind of the super duper basics and just recognizing what the heck do we have in general. So right here in purple, we have two integers, and then most importantly, they have the same sign. Okay, when I say most importantly, I mean it. Like, we need to recognize that even on this next one, we have integers with opposite signs. Okay, so check it out. We have integers, right? That part is pretty obvious. But this guy is negative. This guy is positive. That means they have opposite signs, okay? And you're thinking, okay, well, why does that matter? Well, let's now do this math. What's the product of 3 and 2? Well, it's pretty clearly 6, right? So what did the product produce? It produced a positive number, okay? This one, though, since we have a negative and a positive, when they multiply together, they are going to produce a negative 6, and the sign of that product is pretty clearly negative, right? I mean, it's literally right there, negative. So you might think, okay, well, why, when these two multiply, are they going to be opposites? Or why, why does that give us a negative? Well, let's just kind of keep going, all right? Right here, we have, again, integers with opposite signs. Okay? What is different about this one compared to this one? Well, you could say, well, this 2 is positive, whereas that one's negative, and you could say this 3 is positive, whereas that one's negative. But that really doesn't matter that much because it's still going to produce negative 6, okay? Negative 3 times 2 is negative 6. Our result is negative, okay? And then last one that involves a 3 and a 2, it's not the last one, obviously, on this little page. We have integers. Are they opposite signs? I mean, well, that's a negative and that's a negative. They have the same with the same signs. So this is where, honestly, I think with both of these, that makes sense. A positive times a negative is going to give me that. And here, 2 positive is going to be positive. But this guy, this one, what's he going to do? A negative times a negative is going to be positive. Positive. So if you're looking for like some patterns here, let me suggest a pattern. How about this? When they have the same signs, they're going to be positive. Same signs, positive. Opposite signs, negative. Okay? So take a look here. This next one, we have integers, same signs. 6 times 3 is 18. It's going to be positive, right? Here we have a positive and a negative. We know that this is going to produce a negative because they have opposite signs. So, in fact, I'm going to stop writing integers. I'm just going to write opposite signs. And 2 times 5 is 10, but it should be negative, right? Here we have opposite signs. In fact, hang on. I'm going to do something a little different now. Instead of writing opposite, I'm going to write different signs. Because you are in charge. Put that into your brain. Pick which version of that makes the most sense to you and that will stick in your memory. If they have opposite signs, if they have different signs, then it's going to end up being negative, okay? And then last one here is we have a negative times a negative. these are the same signs. Negative 5 times negative 3 is positive 15. They produce a positive. Now, one thing I want to say is, and I've heard this since I was your age, is that this phrase, a negative times a negative is positive. Like, I've heard that phrase forever, and it's true. I mean, that's what just happened here, that's what happened here, and both of those produced positives, right? So I wanted to show you this to give you like some patterns, to give you another reason to perhaps remember basically this fact right here, okay? Don't confuse this fact, with like when you're adding, for example. So like if I were to go over here and be like negative 3 minus 4, okay, well, that produces a positive. No, it doesn't. That's negative 7, right? So don't confuse this. But then what about the fact of like, what if we had negative 3 minus negative 4? Well, this right here is kind of this right here, right? When you have the two negatives that are immediately next to each other, that produces that positive result. So this wouldn't be negative 3 plus 4 equals 1, right? And then what is negative 3 times negative 4? Well, that would be positive 12. So if you're like, okay, my head's spinning a little bit because you've said a lot of mathy things, here's just what I'm trying to say is the numbers can have different looks, and the different operations produce different results, right? This one was, adding and subtracting. Subtracting. That's what these two were. And then this one is multiplying. That's what we're doing here. And so let's continue to kind of mess with this. What if I flipped them around? Is that going to matter? No. Okay? And then here, now I'm going to do a positive 4 and a negative 3. That's negative 12. I'm going to do a negative 3 and a positive 4. That's negative 12. Okay? I've pretty much represented this in all of its possibilities. Two negatives, positive. Same signs, positive. Same signs, positive. Opposite signs, negative. One positive, one negative, that's negative. One negative, one positive, that's negative. Now, if you're out there having lots of trouble with this, go back to basically when you first learned multiplication, okay? 3 times 4. This is like saying I have 3 groups of 4, and let's use cookies, okay? If I have 3 groups of 4 cookies, okay, then that's 1, 2, 3, 4. That's one group. And 1, 2, 3, 4, that's another group. 1, 2, 3, 4, that's another group. Group. How many cookies do I have? I have 12. Because 3 times 4 equals 12. And so if you're like, well, wait a second. What if it was 3 times negative 4? Guys, it's 3 groups of 4. Hold up. It's 3 groups of negative 4. I was going to say 4 negatives. But negative 4 cookies? And if you're like, what the heck would that look like? Well, let's draw it. So it's like negative cookie, negative cookie, negative cookie, negative, 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 negative. That's one group. Negative cookie, negative cookie, negative cookie, negative cookie. That's another group. Negative cookie, negative cookie, negative cookie, negative cookie. There's another group. How much do we have? If I were to add all of this up, I'd have negative 12. Okay? Now, if you're like, sure, that makes sense, but what about negative 3 times negative 4. Are you telling me that I'm going to have negative 3 groups of 4 cookies? But we have to kind of change our thinking here, and that what we did with the negative cookies is it's almost like we just flipped the cookie over, right? And instead of thinking of it as negative cookies, instead we're thinking of it as like upside down cookies. So what's happening is we're basically going to take this, which was 3 groups of upside down cookies, and then this negative right here is going to say, you know what? Let's upside down those upside down cookies. So if I literally took, in fact, here I'm kind of doing a little copy paste thing. I don't know if you can see me tracing it on the iPad or not, but here I go. If I literally took these and flipped them all back upside down, it would now be positive, 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 and I would now have positive 12. So that way, it's like, hey, we're going to have upside down 3 groups of upside down cookies. So that's why a negative times a negative is positive. And if you're like, no, that does not make sense, let's put it on a number line. I know you were waiting for a number line, weren't you? 3 times 4. Here we are at 0. And what I'm going to do is I am going to take 3 steps forward. 3 steps forward. And in each of those, I'm going to take positive 4 steps. So I'm looking this direction, positive, because that's positive, and I'm going to take positive 4 steps. Okay? So we end up getting 12, right? Now what if I was to do negative 3 times 4? Okay, here's number line, starting at 0. I am going to be going 3 steps in the negative. I'm sorry, I'm going to be taking negative 3 groups. Negative 3 groups. And now I'm still actually facing forward because I'm about to do positive 4. But since I went backwards, that positive 4 ends up being negative 12. And if you're like, wait, how is that possible? Because on a number line, when you walk this direction, you're going positive. On this number line, if we were walking this direction, we'd be going positive. But we were walking backwards, right? And what decided we were walking backwards? That negative 3, okay? And remember, that's negative, so we ended up with negative 12. Let's try, what if we did 3 times negative 4? We need a number line. So now what's happening is we're at 0, and I want to walk 3 groups. I want to walk 3 groups. But here's what's happened. I am looking negative. So what ends up happening is I end up going negative 3 groups like I wanted to, right? I wanted to go 3, but I end up looking negative. So negative 4, negative 4, negative 4. I'm at negative 12. So 3 times negative 4 is negative 12. And if you're like, okay, I understood it with the cookie thing, or you know what, I didn't even need the cookie thing, I got it back over here. If that's you, I apologize for doing all this, but here's the last shot. Negative 3 times negative 4. I'm going to try and help you to get it of like, all right. So we're at 0 as we have been, and I want to walk back. I want to walk back 3 steps. Back 3 groups, right? But now, and this is where this is kind of weird, I'm facing backwards from backwards, okay? This is the backwards direction, but this is telling me to go backwards from that, okay? So I actually end up going 3 groups forward And this is where it's like flipping the negative cookies upside down, flipping the upside down cookies upside down, okay? So again, if you're lost with all this, try and wipe that from your memory. Check out here where we have the same signs is going to be positive, opposite signs is going to be negative. A negative times a negative is positive. Okay, let's wrap it up by talking about these. So let's talk about this stuff. This is an exponent. And some of you guys might know that exponents are just basically repeated multiplication. And in fact, that's what they're trying to communicate right here, is that we have parentheses -2 squared. So that means that everything that's inside of these parentheses is getting raised up to the second power. And this is what that means. It just basically means -2 times -2. And that's why I said exponents are basically repeated multiplication. I mean, just like that multiplication was repeated addition, so we're just making life simpler to get bigger numbers in a more compact way, basically. So -2 times negative, same signs, a negative times a negative is positive. Now, how about this one? What's the difference between this one and this one? Well, a big difference, actually. That negative is not being raised to the second power, okay? Only 2 is, and that's what they tried to communicate here. That 2 is multiplying 2, and that negative is just hanging out there the whole time. So that's why -2 squared is really just -4, but -2 squared is 4. All right, now they're throwing multiple numbers at you, and you don't need to freak out. You got a couple of choices. You can either just literally start on the left and go to the right, or you can kind of pick and choose, and that's what they did here, is they said, hey, you know what? Why don't we do -2 times -5 first? Because in their mind, that was easier. And in fact, how is that easier? Well, because -2 times -5 is really +10. Remember, a negative times a negative is positive. And then, dude, multiplying things by 10 is real easy, because you basically just add a 0 to it, right? That's what they did here. 17 times 10 is 170. But had you just gone left to right like they did, or like I had mentioned, -2 times 17 is -34. And when you multiply that by -5, I'll bet you'll never guess, it's 170, okay? And then they throw a little bit of a curveball at you here, and that they have said, hey, you remember our order of operations? Let's do parentheses first. And so what they do, actually, they just rewrite it. Not really sure why they rewrite it here, but they did. Just that is exactly the same as that. They did this first. -3 plus 4 is 1. Yeah? -6 times 1 is -6, and -6 plus 6 is 0. Now, why don't you try these? If you're actually watching this video trying this stuff, pause it, try them, and then here we go. So this first one, in fact, I literally chose this one because of like how weird these look and how easy they can be, okay? So like 8 times -15, oh man, I don't want to do that. Wait, times 0, anything times 0 is 0, so guess what? That's just 0. Yay. This one, 24, and then hang on. I mentioned order of operations back here, and then I didn't actually write it down. PEMDAS, please excuse my dear Aunt Sally. This is parentheses, exponents, multiply, divide, add, subtract, right? So the reason that we did the 3 plus 4 first is because parentheses are first, right? So now, speaking of order of operations, exponents. Hey, look, exponents. They happen right after parentheses. So let's deal with our exponent here. Is this minus getting raised to the third power? Nope. So this is negative 3 times 3 times 3, which is 27. So this ends up just being negative 3. And in fact, what ends up being 24 minus 3 cubed equals negative 3 right there. Slide over here. Parentheses, they happen first, right? So 10 minus 7, negative 2. 10, and then now, sorry, I kind of got ahead of myself because really after you've done just a few of these, you're going to be like, this is easy. This clicks for me. This is negative 7 times negative 2. A negative times a negative is positive. So what about this 10? Is it just 10, 14? No, it's going to be 10 plus 14, right? Because those are positive now. And then 10 plus 14 is 24, okay? Now, you also did have to do this in PEMDAS order. That was important because let's see if you had not done it in PEMDAS order. Well, first of all, maybe you would have done 10 minus 7, and that's 3. So here, by the way, I'm just going to go ahead and say this is the wrong way. Wrong, okay? And then you would have been like, oh, okay, well, 3 times negative 2, that's negative 6. Wrong, right? That's one wrong way of doing it. Let's see another wrong way of doing it. What if you had said, oh, okay, 10 minus 7, and then I see that this is negative 2, but you still decide to do 10 minus 7, well, you'd get 3, and 3 times negative 2 is still negative 6, and that's still wrong. I'm sure there are other wrong ways we could have done this, but let's just focus on the right way, that you do parentheses first, then exponents, then multiply, then divide, then add, then subtract. Okay?